These are numbered strangely, but it's still okay. The next problem, a triangle has vertices. After dilation, the coordinates are this. Remember whenever we do dilations, to find the scale factor, we always do new over old. Well, let's put the new, 8, 14, for A prime, over A, which is 2, 3.5. And then I'm just going to do B. B prime is 0, 24, and B is 0, 6. And C prime, oh, this is B, and C prime is negative 2, 3, and negative 8, 12. And I'm going to look at any of these, and I'm going to do new over old. Well, the nice thing is this one right here is 24 divided by 6 is 4. And I'm going to look at this and go 2 times 4 is 8, 3.5 times 4 is 14, 0 times 4 is 0, 6 times 4 is 24, negative 8. Do I have these backwards? I do. I have those backwards. Sorry, my apologies. There goes my whiteout again. That's why you use pencil. Negative 8, 12, and negative 2, 3. Negative 2 times 4 is negative 8, and 3 times 4 is 12. And if you did it in reverse, 8 divided by 4. So my scale factor is 4. Now, my scale factor, anytime I'm doing dilation, I would encourage you to write the word multiply. Because what did I do to this x to get this x? I multiplied by 4. And what did I do to this y to get that y? I multiplied by 4. And so your algebraic rule is 4x, 4y. Dilation always means multiply. Okay, we have another triangle. What are the coordinates after the triangle is rotated 180? Remember that 180 is the little skis. And so what you're going to do is you're going to put these coordinates on top of your skis, and you're going to go 1, 3, change sign, negative 1, negative 3. Oh, but we want k prime, so 8, negative 3 would come down as 8 changes signs to become negative 8, negative 3 changes signs to become positive 3. It is 8, negative 3. Woo! Did not. Look at that whiteout again. I copied K. Oh, pay attention. Okay, so my K prime is negative 8, 3. A fashion designer draws a dress with a sash measuring 0.5 by 4 inch. Okay, so I draw it. And it's 0.5 by 4. The sash measures 7 inches. So the sash is here, and she draws it from existing. So really, this is the new. The drawing is the new. So the sash is 7 by 56. Remember new over old. Okay, new is 4. That's longer than that, so I have to pick up the longer one. And when I simplify, and it does, I get 1/14. Now, the sash was bigger, and when I was looking at it, I drew it smaller, so it did have a dilation of a reduction, and we know that that's a reduction because it's less than 1. What are the coordinates of the rotated 270 clock? So we know that it crosses. We know negative 1 goes here and 3 goes here. I go 90, 180, 270. He slides down with no change. He slides down with a sign change. -3, -1. Triangle has vertices. The triangle is dilated. What do I write on top of dilated? I write multiply with a scale factor of 3 and the dilation centered at the origin. Write an algebraic expression for the dilation. When I dilate, I multiply. So I take my x and I multiply it by 3, and I take my y and I multiply it by 3. Determine the coordinates of image of point A. So 1, 4. So 1, 4 is A. And I multiply 1 times 3. And I multiply 4 times 3. And there's A prime. Okay, on the graph is a dilation. Okay. And I have to decide whether it is a enlargement or a reduction. And so my new is always my prime. So I went from this to this, so it's a reduction. So I know that my scale factor is going to be less than 1, because that signifies a reduction. I'm going to look at this flat side right here, and that's 2. And remember that we can do dilations as new over old to discover scale factor. So I'm going to put 2 up there, and I'm going to go 1, 2, 3, 4, and that simplifies to 1/2. And I'm going to check it out, and I'm going to go 1, 2, 3, and then the vertical here is 1, 2, 3, 4, 5, 6, and 3 over 6 is still 1/2, so I got it. Is the dilation an enlargement or a reduction? Well, I know that since it went from bigger to smaller, because this is the new, it was a reduction. And I'm going to stop there to do another part for the next couple of problems.